Hi everyone. In this video I will be demonstrating polynomial regression with covariates using SPSS, and in particular I'll be focusing in on identifying and describing a quadratic functional relationship between a focal independent variable and the dependent variable. So the example that I'll be working from is based off of one that's presented in Chapter 12 of Darlington and Hayes' 2017 book, Regression Analysis in Linear Models. And in that chapter, they kind of walk through sort of a hierarchical strategy for testing different nonlinear relationship possibilities. And so what I'm going to be doing in this video is kind of walking through those models. There's no treatment of SPSS in that presentation, so that's really kind of where I'm going to be picking up in this particular video. So as you're looking at the models that are on the screen, you can see that we've got three models. We've got a linear model, we've got a quadratic model, and then we've got a cubic model that are given. So in the example, we have basically we have predictors of a measure of political knowledge. So in the linear model, we've got news consumption, which is kind of the focal independent variable, if you will, along with three covariates. We have gender identification, age, and socioeconomic status. And so in this linear model, we have news as a linear predictor of political knowledge. In the second model, the quadratic model, we've got news and the square of news as predictors that are incorporated. And so basically this is forming a compound variable that allows us to model a nonlinearity between news consumption and political knowledge. Again, we're maintaining those covariates in this particular model. The last model that you see, model 3, is a cubic model, and this is not really going to be one of particular emphasis in this video, but I'm just kind of incorporating it just to show you that you can model higher level or higher order polynomial relationships. In this case, we've got news consumption, the square of news consumption, and then the cube of news consumption as predictors of political knowledge. Now, I do want to mention before we start with the actual demonstration that you can obtain a copy of the data that I'll be working from in this video by downloading it following the link that's provided underneath the video description. I've also created a supplemental PowerPoint that you might find helpful as we go through the video presentation. It discusses a lot more of the nuances that I'm going to be really covering in the video talk. The last thing I do want to mention too is that polynomial regression can get a little bit complicated at times, and so this video is not going to be focused on all aspects of decision making or strategy with respect to this type of analysis. So if you want to get into those that level of detail, I'm going to defer to the Darlington and Hayes chapter for that, as well as other treatments such as Cohen et al. From their 2003 book and Aiken and West. And I've incorporated references to all three of those in a slide at the end of the PowerPoint presentation. Okay, so here we are with the data set, and as you can see, again, we've got political knowledge. This is going to be our dependent variable. Our focal independent variable is going to be news consumption, and then we have our covariates, age, gender identification, and socioeconomic status. The gender identification variable, just so you know, it's dummy coded. Basically a value of 0 indicates a person identifying as female, a 1 indicates a person identifying as male. So we're going to start out with the linear model just to kind of look to see if there's any evidence of any type of nonlinearity in terms of the relationship between news consumption and political knowledge. So to accomplish that, we're going to go to Analyze, Regression, and then go down to Linear. And let me reset this and I'll kind of set it up for you here. So we've got political knowledge, move it over to the dependent box. We'll move news consumption over along with age, SES, and let me see if I can find it here. There's gender ID right there. So there we have our focal independent variable and our three covariates. I'm going to go ahead and click under statistics. I'll ask for part and partial correlations and collinearity diagnostics. There's other things I ordinarily would be asking for, but I'm going to be just mainly focusing in on a few things in our output. Next, I'm going to click on Save and click on Residuals, more specifically unstandardized residuals. and we'll click on continue and then on OK. So first off, you can see we've got our model summary table and the ANOVA, which allows us to kind of look at the overall fit of the model. You can see that the R-square value is 0.32, and we also see that the F-test is indicating statistical significance. So the R-square is, that's our estimate of the population R-square. So we're estimating that the predictors would account for about 32% of the variation in political knowledge. And the F-test is allowing us to make an inference about the population R-square, whether it's equal to or greater than 0. So we're going to reject the null and infer that the population R-square is greater than 0. We can scroll down a little bit further and you can see that we've got our coefficients table. And as you can see, we've got news consumption right there. There's the unstandardized regression slope. So it's positive, and we also see that we have statistical significance. So we would basically be inferring that news consumption is a positive and significant predictor of political knowledge. And you can also see that with respect to the covariates, age actually turns out not to be a significant predictor, but we have SES as a significant positive predictor of political knowledge. And then gender ID, given that coefficient is positive, and given our coding of that variable, that's indicating that males are scoring higher, or expected to score higher on political knowledge than females, and that difference is statistically significant. So in our data set, because we had clicked save the unstandardized residuals, we now have this column of those residuals. And so now what we're going to do is we're going to plot these against the values on news consumption, which is our independent variable. And so what we'll do is we'll go to Graphs, Legacy Dialogues, go down to Scatter Dot here. We'll click on Simple Scatter and Define. We'll move unstandardized residual up to the up to the y-axis box, and then move news to the x-axis and click on OK. So as we're looking at this, what we would want, in terms of the relationship between the residuals and news consumption is no relationship and just complete random scatter of dots, if you will. And so what you can see here, though, is that there might be some indication or evidence of kind of some curvature in those residuals. So if you kind of follow the general pattern right here, I'm just kind of drawing it out freehand the best that I can. It looks like there may be some indication of curvature in those residuals. Now, if there is any type of curvature in those residuals, what that would be signifying is that we did not completely or adequately account for the entire relationship between news consumption and political knowledge. We modeled political knowledge as a linear function of news consumption, and so if that was actually the case, we would expect the residuals to be more randomly dispersed with no indication of kind of any type of curvature. But instead, it looks like we might have some curvature, so that might be an indication then that the relationship between news consumption and political knowledge is nonlinear. If I want to take a little closer look, I can double click in this box right here and go up to where it says add fit line at total, and I can click on that. This is just a linear fit line right here. You can see the R square is basically 0, but that's not really what we're interested in. We want to look to see if there's any type of curvature. So I'm going to click on this lowest option right here and then apply, and you can see that in terms of the fit, it looks like there is some indication of curvature going on. I could even click on Quadratic right here and click Apply right here, and you can see that curvature a little bit more clearly right here that's taking place. So it might be the case then that we want to model this relationship as quadratic. Now, just because there's some visual indication of curvature in those residuals, we do want to test that possibility out. So this is where we're going to adopt a hierarchical strategy for testing for a curvilinear relationship between news consumption and political knowledge. So in this case, we're going to perform a hierarchical regression. We're going to be adding in the linear news variable first in kind of model 1. In model 2, we're going to be adding in the square of news consumption, and then in a model 3, we'll be adding in the cubed version of news consumption. Again, that cubed news consumption variable, we're just kind of incorporating that just to show you that you could model higher order polynomial relationships if you wanted to, but that's not really, again, going to be the focus in this discussion. So it is encouraged that before you start adding in power terms of a variable, as we're going to be doing in the case of our polynomial regression, that you mean center that variable first. So what we're going to do is we're going to take this news variable and we're going to center it at its mean. So to do that, we need to actually generate our descriptive statistics. I'll go to Analyze Descriptives right here, and let me just kind of reset this. And we'll go down to news variables right here. Okay, and so you can see that the mean of our news variable is 3.313971. That's kind of the most exact value right there. So I'm going to take that value, and we're now going to go up to transform compute variable, and this was just kind of me playing around with something earlier. So what we'll do now is we're going to type in news under a target variable _c, and this is just my own naming of this variable. This is an arbitrary name, whatever you put in the target variable. So we have news _c. In the numeric expression, I'll type in news minus, and then that value that we had in our table right there. We'll click on OK, and so now we've got the centered news variable that's given. Alright, so now we have that available for Model 1, if you will, modeling news consumption as a linear predictor of political knowledge. But we also need to square this and also cube this. So to do that, we'll go back to Transform Compute Variable. I'm going to reset this, and so I'm going to create a squared variable, if you will, and we'll just call it news _c _sq for square. And for numeric expression, we'll just take our news _c variable, 2 asterisks and then a 2, and that's basically raising the original news, the centered news variable, to the second power. So this is what we're doing right here. So we'll click on OK, and so now we've got the squared news variable added, and that we'll also do it for the cube. So now we'll go back to compute. I'm just going to create another variable name. We'll call it news _c _cu, and in this case we'll just change this to news _c double asterisk and then 3, because we're raising this news c variable to the third power. So now we'll click on OK, and so now we have everything we need to carry out our hierarchical regression. So next we'll go to Analyze Regression Linear again, and we already have our original model, but I'm going to take this news variable out and I'm going to put in the news _c variable in. So that is our, again, this model right here is going to be capturing the linear relationship between news consumption and political knowledge. We're going to click the next button right here, and we're going to add in news _c _sq for squared. So we're going to be adding in our squared news variable right here. We'll click next again, and then we'll add in our cubed variable. So we'll move that over there. Where it says statistics, we're going to go back under here and we'll click on R squared change and then continue. And I'm going to go ahead and leave this clicked for the unstandardized residuals, as you see right here. So we'll click, or actually what I'll do is I'll kind of unclick this for the time being. We'll click on continue, and we'll just go back and click on OK right here and run our analysis. So I did not want to generate the residuals just yet. I'll show you something in a second. So as you can see right here with our model summary table, we've got the R squares for each of our models. So model 1, that's just our original linear model. Model 2 is our quadratic model, and then model 3 is our cubic model. And you can see the R square value again for the original model was 0.32. For the quadratic model, we see it's 0.336. So there's an increase right there of about 0.016 with respect to the R square value. And that change is reflected over here in this R square change column, there's the 0.016 right there. Then the R-square for the third model is 0.338. So it's very, very small, and you can see the R-squared change right here is about 0.002. So it's, we have not much change in our R-square value. Now, in terms of making a decision among our models, again, we have our linear model that seems to be doing a pretty good job overall in terms of accounting for variation in political knowledge. We see that the R-square value is the 0.320, and that model we have statistical significance. So we're doing a pretty good job just with that model alone. In terms of the change in R-square, the increment in R-square, we did increment of 0.016. So by virtue of adding in the squared news variable, we did account for an additional 1.6% of the variation in political knowledge. And that's not a huge amount, but that is an increment nonetheless. Now, we want to test whether that increment is statistically significant. And so to do that, we can look over here in this column right here. We've got this p-value that's given. It's actually an f-test. I'll just kind of show you right here for that change. And so you can see we've got the f change, the degrees of freedom, and then the p-value is 0.005. So, kind of adopting the conventional alpha level of 0.05. You can see that the p-value is less than 0.05. So we would basically be inferring that by adding the news squared variable, we're accounting for a significant increment in variation that's accounted for. Now, with respect to the last model, you can see right here we have our R-square of 0.338, the R-squared change of 0.002. The question is, was this increment significant? Did we account for significant additional variation by adding in that cubed variable right here? And you can see that the change was not statistically significant. So looking at our results in our change statistics over here and so forth, it would appear that of the two options in terms of the quadratic and cubic models, the quadratic would be the preferred model that's given right here. So this is our preferred model. So we're going to go with the idea that the quadratic model is the best model of our three models, because we did add additional variation in terms of the the variance accounted for. Again, there's our R-square value. We did increment over the linear model. It wasn't a whole lot, but we did see an increment of 0.016, and we also found that that increment was statistically significant. So we are going to stick with that model as our preferred model moving forward. As we scroll down and look at the coefficients table, we are going to want to interpret the results for model 2 right here. So there it is right here. And so we've got our news C variable, and then there's our regression slope for it, and our significance. So you can see that's significant, obviously. And then there is the squared news C variable, and you can see that that is significant. And just so you know, the t-test for the higher powered term is equivalent to the f-test for the R-squared change from model 1 to model 2 in this particular case. So just kind of keep in mind that as we include higher order terms in our polynomial regression, that highest term, the t-test for the highest term, is equivalent to the f-test of the change in R-square from the model that did not include that highest order term to the model that does include it. So you can see right down here the t-test for the cube term. You can see that there's our p-value 0.30, and that is equivalent to the test of R-squared change from model 2 to model 3. So at any rate, looking at our results, we're going to stick with model 2, and because that model is the one that we are going to stick with in terms of the correct functional specification of the relationship between news consumption and political knowledge. That's going to be the model that we are going to use when it comes to interpreting the effects with respect to our covariates. So that's, again, our results are going to be any kind of write-up that we would be going with, we would be sticking with model 2. Okay, so now what I want to do is to go back and generate the residuals for model 2. So I'm going to go back to linear, and I'm just going to kind of reset. Well, actually, we'll just kind of remove this altogether. Actually, we'll just reset this. Move political knowledge in along with our news C, our squared news variable, along with our age, our gender ID, and our SES, and then we'll click on save right here. We'll click on unstandardized residuals, continue, and then on OK. And so now we've got our new column with the unstandardized residuals, and so we're going to plot this against our new C variable, if you will. So we'll go down to graphs, legacy dialogues, scatter dot, simple scatter, and define. And we'll move this out, and we'll move our unstandardized residuals in. It really doesn't matter. We can plot this against the original news variable right here, or against the news C variable. The plots will be exactly the same. It's just that the x-axis scaling will look a little bit different. So I'm just going to move this on out, and we'll put the news C variable in, and then click on OK, so we can look to see if there's any kind of evidence of curvature in these residuals. So it might kind of give you a visual, as you're looking at this, and you might get the sense that maybe there's still some curvature, but we can kind of look at this a little bit more closely by double clicking in the box right here, and we'll click on add fit line at total. So you can see that if I click on lowest option right here, you can see that there's not really any strong indication of any type of curvature that's going on. And because we modeled that relationship as quadratic, we'll click on that right there and click on apply. You can see that the R square for this model is actually there is 0, and that's because we took into account the quadratic relationship between news consumption and political knowledge when we just ran our analysis. So if there was any type of remaining curvature, then it might be a result of perhaps a better specification of being perhaps cubic or something of that nature. But because we've are seeing that there's no real indication, again, if we go back to lowest right here, no real indication of any type of curvature that's going on, it doesn't appear that there's any type of higher order polynomial that would do a better job in terms of explaining the relationship between news consumption and political knowledge. And once again, we've already kind of demonstrated that too when we looked at or when we carried out our hierarchical regression. We found no effect for that cubic term for model 3. So at this point, you might be interested in graphing the relationship between news consumption and predicted values on political knowledge. And so basically this is a nice way of kind of allowing the reader to kind of visualize that relationship a little bit more clearly. So to accomplish that, what we're going to do is we're going to be taking values from our final regression model and generating predicted values on political knowledge, and then we'll create a scatter plot where we're plotting out those fitted or predicted values against values on news consumption. So really quickly, I want to show you the prediction equation from our regression analysis. And so really briefly, our intercept for that model for model 2 was 10.002. The regression slope for news consumption is 0.339. For the square of news consumption is negative 0.156. For age, it's 0.022. For gender identification is 1.72, and then for SES it's 2.472. So what we're going to do though is we're going to generate our predicted values, but we're going to be holding our age gender identification and SES variables constant at a given value. And so what we're going to stick with is the mean of each of those variables. So we're going to take the mean of age and substitute it into this equation, the mean of gender identification, we're going to substitute it, and also the mean of SES. Again, we're going to be substituting all those means into this equation right here. And then by virtue of doing that, when we construct our predicted values, then we can plot those predicted values against news consumption, again, while holding those covariates constant at their means. So basically what this is going to entail in SPSS is that we're going to need to generate descriptives for our covariates in the model. So I'm going to go to descriptives right here, and we'll kind of reset this. I'm going to move age over gender ID. And by the way, this is perfectly permissible to add in the mean of our dichotomous or dummy-coded variable right here, gender ID. We'll also move SES over to this box right here, and we'll click on OK. And so now we have the means of our covariates that are given in this column right here. So you can see the mean age is 44.93, mean gender identification is 0.48. Basically that's indicating that 48% of our sample was containing persons identifying as male. And then we have a mean essentially of 0 for SES. So now what we'll do is we're going to go to transform compute variable, and I'm going to reset this. And so now I'll create a new variable. I'm just going to call it political knowledge or Paul knowledge, Paul no, and then we'll kind of have a little underscore right here, and then we'll type in PRED right there. So with the numeric expression, there are a couple of ways that we can do this, but basically what I'm going to do is I'm going to scroll up here to our results with respect to the coefficients table, and now it says model 1, but this is basically our model 2 from that hierarchical regression. And we have our coefficients that are given right here, so we're going to be using these coefficients and then performing the remaining substitutions. So for our intercept, we'll type in 10.002. Then for news consumption, we'll type in 0.339. Whoops. And then asterisk, that's indicating multiplication, then news underscore C. So that's the name of our news consumption variable right there. Then we'll type in a negative 0.156 and then asterisk, and then we'll type in news underscore C underscore SQ. So that is incorporating our squared news variable. Then plus 0.022. And then times. Now where it says age, remember that we're holding age constant. So what we want to do is we want to take the mean for age, which is 44.93. So I'm going to type in 44.93 right here, and then plus, and we'll scroll back up here and just go to gender ID, which is 1.720. Right there, and then times its mean. And remember, it was about a 0.48. I believe that was the mean in our descriptives table. So then we'll type in plus, then 2.472 times, and remember that our mean for this was essentially 0. It's 0.0003. I'll go ahead and put that in there, just even though basically it is 0 right there. So now you can see we've got the regression slopes for each of the covariates times their respective means. And so now when we click on OK, we get our column of predicted values for political knowledge. And in the slideshow that I put together, I actually just took the original equation right here and then substituted those means in right here, here, and here, and then just kind of went through the derivation all the way down to this is the final equation with respect to the effect of news consumption on political knowledge. So this was the final equation that I used right there. It's going to generate the same thing as what we just did in this particular video presentation. And in fact, this is kind of me just walking through that using that particular approach, and so we end up with the same exact predicted values. Okay, so now let's go ahead and graph our relationship between our political knowledge, the fitted values for political knowledge, and news consumption. So to do that, we'll go up to Graphs, Legacy Dialogues, go back to Scatter Dot. Right there, we'll move our residuals out, and we'll move the predicted values in, and we'll click on OK. And so now you can see the relationship between news consumption and those fitted values. Again, we're holding those covariates constant at their means. And so as you can see, we've got a nice bowl shape in our output right here, and you can see that because we have this bowl shape, basically kind of an upside down bowl, nevertheless, but it is a bowl shape. Basically what this is indicating is that relationship between news consumption and political knowledge is not constant, but rather as we move from lower values on news consumption to higher values, you can see the slope becoming less positive. So you can see that the slope at lower values on news consumption is much more positive. As we kind of move towards more intermediate values right here, the slope starts to level off, and then as we move towards higher values, we see that the slopes are becoming increasingly negative. Okay, so that is basically all I'm going to show you in this particular video. I will mention that in the PowerPoint I do go into a little bit more discussion on how to generate those simple slopes, if you will, basically slopes of the relationship between news consumption and political knowledge at different values on news consumption. I kind of introduce a little bit of discussion of derivatives. So if you have any background in calculus, that might be something that you remember. So the basic process, though, of generating those simple slopes and then plotting them is very similar to what we just did with using the transform compute menu and the scatter plot option in SPSS. So at any rate, that is going to conclude this video presentation, and I appreciate you watching.